So this is problem 1, practical kinematics 2, and there are 2 planes, plane A and plane B. Plane A 600 kilometer per hour with velocity, and velocity of plane B 500 kilometer per hour, and the direction is shown on the finger, and the angle theta 75 degrees. So let's put it down, 75 degrees. And the question is, determine the velocity of plane B with respect to plane A. So basically this is a relative velocity calculation. So plane B with respect to plane A, so we start the relative velocity equation with VB equal to VA plus VB relative to A. If they ask what is the velocity of plane A with respect to plane B, then you start with VA equal to VB plus VA relative to B. So with that, we solve with components and scalar equation. And if remember in in statics equilibrium, 2D or 3D equilibrium, we draw the diagram. So we do the same here. We call it kinematic diagrams. So VB, as you can see, go to the left. So let me assume the positive x and y direction as usual that we do in statics. X go to the right, y go up. So VB go to the left. So let's draw that out. The kinematic diagram in here, VB. So velocity of plane B here, 500 kilometer per hour. Equal sign, let's put that. Equal to VA's, go down, 75 degree in there. So let's write out VA, and the magnitude is 600 kilometer per hour. The angle there 75 degrees angle theta, plus VB relative to A is an unknown, so we can assume positive, you can assume it directions, and because it's a vector, so you can put it at a x component and y component. So you have that is VB relative to A, velocity of B relative to plane A, and in this case in x components, and similarly VB relative to A in y components. And when you have the diagram, you can project those diagram and vector into x and y components, just like we do sum of all the forces in x, sum of all the forces in y in 2D equilibrium. So let's do the same here. Let me sum up all the vectors, not forces in this case, right? So sum up all the vector in x direction and assume go to the right is positive. So as you can see, VB go to left, so it's negative 500 equal VA 600 and adjacent to the angle 75 for x component. So you have cosine 75 degree, and it's positive, so it will be plus. And we draw in diagram, we assume VB relative to A in x component go to the right. So you have plus VB relative to A x components. And this is one equation, one unknown. You have VB relative to A x components equal to negative 655. Negative means opposite to our assumed direction. We assume go to the right, then the actual direction is go left. So go left. So that is the x component of the relative velocity of plane B relative to A. Similarly, we can project that diagram or velocity vector, relative velocity vector in y direction, assume going up. So VB horizontal, go up, vertical, it has to be 0, equal VA going down. So you have 600 sine 75 degree going down, negative opposite to your assume positive direction, plus y, vb relative to ay. So we can have from the diagram, so vb relative to a in y components. So also one equation want to know, we can show vb relative to a, velocity of plan b relative to plan a in y components is equal to 580 kilometer per hour. By the way, put here the unit kilometer per hour. And that one is positive. It means same as your assumed direction. We assume going up in the diagram, so it could be going up. So we have two components, just like in 2D forces. When you two components, you have the resultant forces, or in this case, resultant vector of b relative to a equal to square root, right? So b relative to a magnitude equal to square root of 655, which is square, which is the x components, and then 580 square with the y components, and we get 875 kilometer per hour. So that is the magnitude. But since this is a vector, we need to find out the direction. And my only suggestion for you is always draw a big diagram so that we can see and easy to visualize what should be the answer. So v relative to ax in 655, go to the left. So we have here vb relative to ax equal to 655 kilometer per hour, and vb relative to ay 580 going up. So vb relative to a in y direction 580 kilometer per hour go up. So the resultant of velocity of plan b relative to a, you use the parallelogram. So parallelogram here, the diagonal line of this rectangle should be the velocity vector of plan b relative to a. And to find direction, just like in 2D forces, we want to find this angle alpha, and it equal to the opposite. To find that alpha, if you recall, alpha equal to inverse tangent of the opposite here 650, no, opposite is 580 kilometer per hour divided by adjacent 655. So let's write down here 580 divided by 655, and that you get 41.5 degree. So your answer is, you already know the magnitude and you already know the angles, so you can answer the velocity of plan b relative to a equal to 875, just like in 2D forces, by the way, kilometer per hour at 41.5 degree. And as you can see, this is alpha here is clockwise, so clockwise from negative x-axis. So that is the velocity of plan B relative to plan A, and that is the same answer that we did with the graphical method on the other video.